Let's look at a very specific example out of your book. This one is 9x over 5 subtract 7 is greater than or equal to negative 3x plus 12. I notice that we're dealing with a fraction. Typically when we deal with fractions in equations or inequalities, we start by simplifying the equation or inequality as much as we can first. So in this case, we're going to start by adding 7 to both sides of the inequality. And I end up with 9x over 5 is greater than or equal to negative 3x plus 19. Now, one path to go from here is to find a common denominator between these two terms and combine them. I'm going to take a different tact. I'm going to actually get rid of this fraction because I don't like working with fractions. And one of the things that's true in equations and inequalities is if I do something to one side, I maintain equality by doing the exact same thing to the other side. So I'm going to bust up that fraction. In order to do that, I'm going to multiply both sides of my inequality by the same value. So I'm going to multiply the left side by 5, and I'm choosing 5 because that's the denominator I'm trying to get rid of. Since I'm multiplying the left side by 5, I'm going to multiply the right side by 5 also. When I multiply the left side by 5, I end up with 5 over 5, which is 1, and they essentially cancel out. And I get 9x is greater than or equal to, on the left side, I'm going to distribute this 5 across my two terms, and I get negative 15x plus 95. So now I don't have any fractions to deal with. I'm going to add 15x to both sides because I would like my x terms all on the same side. I end up with 24x is greater than or equal to 95. In order to solve this, I need to isolate my variable. I'm going to divide both sides by 24. And I get x is greater than or equal to 95/24. And I'm going to leave it like that because it's an exact answer.